Now we're going to look at adding organometallic reagents to aldehydes and ketones. So what this name means is we have an organic portion, some carbon portion, and a metal. Well, what we essentially have here is a carbon nonmetal bonded to a metal. And the way we're going to think of this is dissociating it into ions. The carbon will be a nonmetal anion, and then the metal we'll treat as a spectator cation. So there's a couple of types of organometallic reagents. We have what are known as Grignard reagents. And in Grignard reagents, we have a carbon, which I'll abbreviate as R, bonded to magnesium bromide. And again, we're going to dissociate this and treat it as R minus nucleophile plus the magnesium bromide cation. So this could be things like methyl magnesium bromide, which we'll treat as just CH3 minus, or we could have longer chains like propyl magnesium bromide. Again, just break that apart and think of that as the propyl nucleophile, where the carbon that's bonded to the metal is the nucleophilic carbon, the carbon with the negative charge. And it doesn't even have to be sp3 carbons, so we can see things like phenyl magnesium bromide, which is phenyl minus, and remember phenyl is this aromatic ring. So that's what that looks like. Or we can have even a double bond. Again, here's our carbon bonded to the metal. And when you break that up, that becomes the nucleophilic carbon. So we have, if you want to draw the lone pair there, you can, and a negative charge on that carbon. Now we have also organolithium reagents. So instead of the magnesium, we have R bonded to a lithium. Effectively, for our purposes, these are going to be treated the exact same way as Grignard reagents. So we're going to think of this as R minus, and then a lithium cation. And you can have the same Grignard reagents as you do organolithium reagents. For example, instead of methyl magnesium bromide, we can have methyl lithium. We're going to treat this the exact same way as CH3 minus, a nucleophile. And we can write any of these as organolithium reagents. So for us, we're going to use Grignard reagents and these organolithium reagents interchangeably. Let's look at a couple of examples where we add an organometallic reagent to an aldehyde or ketone. So what we see are two-step reactions where we start with an organometallic reagent, followed by step 2, which is an aqueous or acidic workup. And we're going to see why we really do need that in the reaction. Now what you want to do is analyze your organometallic reagent and break it apart. So in this case, we have a Grignard reagent, methyl magnesium bromide. So this will be CH3 minus and magnesium bromide plus. The part we care about is the CH3 minus. That's our nucleophile we're going to be using. So let's go ahead and take that, and we're going to add that to the carbonyl carbon, forming a new bond. That will then push these pi electrons up to the oxygen as a new lone pair and a negative charge. So here's our intermediate. So we've added the nucleophile forming a bond with the carbonyl carbon, and that O, double bond O, becomes O minus. But we don't want to stop at just this charged intermediate. So this is where step 2, the acidic or aqueous workup, comes in. That's going to provide a source of protons to protonate this negative oxygen. So step 2, we add acid to the reaction flask. Once you add the acid, then this O minus reacts with that, forms a bond with that proton to give you an alcohol. So the product has the organometallic reagent added to the carbonyl carbon, the carbonyl oxygen becoming an OH. Okay, let's look at a second example. In this case, we have a ketone, which really doesn't change anything compared to the aldehyde. Our organometallic reagent is a lithium reagent. Still, we're going to treat that the same way. So let's break the bond between the carbon and the metal. So what does that give us? That gives us this double bond with a negative charge and lithium plus. We don't care about the lithium plus. So what's going to happen here? Here's our carbon-carbon double bond nucleophile. Okay, if you need to draw in the atoms, you can. Here we have a CH2, and on that end is just a CH. So this carbon with the negative charge, that's going to form a bond to the carbonyl carbon. So that becomes O minus. Here's our new bond. I'll draw that one in green. And that new bond has the 2-carbon alkene attached. Just like that. Okay, you can write in the CH and the CH2 on here if it helps, or you can just leave it as a skeletal structure. Again, we're stuck here until we do the aqueous acidic workup. In this case, I wrote it a little differently. I wrote it as dilute H+, but it's doing the same exact thing. So we add H+, and that protonates the oxygen. So we're left with an alcohol and that nucleophile added to what was the carbonyl carbon.